morning and welcome to the IperionX Limited Investor Webinar. My name is Jane Morgan and I am the Investor and Media Relations Manager. Today I am joined by our Managing Director and CEO, Taso Arima. Today we'll be running through the recently lodged investor presentation followed by a Q&A session. So to ask a question throughout today's presentation, please use the Q&A function which can be found at the bottom of your screen. Taso, I'll hand over to you.
Thanks very much, Jane, and I really appreciate you setting this up. It's been an absolute pleasure to work with you and the JMM team to set this up. So my name is Taso Arima, or Anastasios in full. I am the co-founder and CEO of IperionX. I started the business in 2020 with my team, and we have been developing this business over the last few years. IperionX was born out of a vision to reshore a titanium metal supply chain. And it was born off the back of our success in another company which me and my team founded, which is called Piedmont Lithium, which is now listed both on the NASDAQ and the ASX. And in that company, we started it in 2016 with a vision to reshore a lithium supply chain. And today it's become a $1.5 billion listed company that has operations in Canada, the US, and in West Africa. So I live in the United States. I'm in Perth at the moment, but I lived in the United States. And in 2020, me and my team, we wanted to look at reshoring a titanium metal supply chain. The last titanium metal refining facility had just been announced that it was going to shut in the United States. It's called a titanium metal sponge plant. And so we saw a strategic need for a reshored titanium metal supply chain. So over the last few years, we built IperionX, and today we're sitting here with a vision of sustainably reshoring a titanium metal supply chain in the United States. And in addition to that, making titanium metal cheap enough or more competitive so that it disrupts or competes against stainless steel and aluminium, where it's a far superior metal, but it's historically been held back because of its cost. Now, as a quick primer before I get into the body of the presentation, titanium metal is a superior metal. The titanium that we typically manufacture today in our facilities in Salt Lake City, 3 times as strong as stainless steel and even far stronger than aluminium. Far lighter weight than stainless steel, so 45% lighter typically. So really important for a lot of different sectors, including electric vehicles and defense and aerospace and consumer electronics. And then it has a range of other amazing properties, but one of the other key properties is corrosion resistance. It's far more corrosion resistant than stainless steel. So the idea here is if you put stainless steel, or the data is if you put stainless steel into seawater, it would corrode in probably about 5 years. If you put titanium metal into seawater, it wouldn't corrode. There's no data on when it corrodes. It has superior corrosion resistance and thus is used not just in lightweight applications, but in applications where you want corrosion resistance. And we can talk about that as we go through the presentation. So the vision is reshoring our titanium metal supply chain. Well, how do we do that? So the way we're building this business is we're starting with the refining capacity first. And that is based on a technology that was secured, that was developed out of the University of Utah by Professor Dr. Zach Fong, and it was funded by the Department of Energy. The Department of Energy funded it for looking at a cheaper source of titanium metal production to create or to allow for titanium metals use across the vehicle industry for lightweight. So this technology not only allows us to process titanium minerals, but also allows us to create a fully circular or fully recyclable titanium metal business. Today, titanium metal, both scrap market and the ability to process titanium metal, you don't have full circularity or full recyclability. But with the processing technology that we've secured, which is all patented, we're able to develop a fully 100% recycled titanium metal business to start. There is a lot of scrap in the market today, which we can take from, and we are interacting with various forms of scrap today, or scrap providers. But we're creating that business first, and we can create a very large business just off titanium recycled scrap today. We're doing it today. We're doing 100% titanium metal recycling today. We're doing it with 0 Scope 1 and Scope 2 carbon emissions as well. And as we scale this business in the next 2 to 5 years, we also bring down the cost of titanium metal and start to take market share from stainless steel aluminum. But over the longer term, we also eventually, once we've been able to recycle as much as scrap as we can get back into circulation, we will want to continue to scale the business. This is 5 to 10 years out. We eventually want to backward integrate to a source of titanium minerals. And that's where we own the Titan project, which is a large titanium mineral deposit, the largest titanium mineral deposit in North America today. Also has a co-product of rare earth minerals and zircon minerals as well. So we're building this business starting on that breakthrough technology, which allows us to build a recycling business first, bring back titanium metal to be 100% recyclable, low carbon and lower cost, and then backward integrated. So we create a fully integrated raw material through titanium metal, fully circular titanium supply chain in the Western world. So why the focus on titanium? As I described, or as I said at the start of the presentation, we really started focusing on it when the last titanium refining facility announced that it was going to shut in 2019 and subsequently shut in 2020. These are called Kroll sponge plants in the industry, from the inventor of the first commercial process to manufacture titanium metal, William Kroll, in the 1950s. They were actually developed and scaled in the United States, but today there is no titanium Kroll facilities remaining in the United States. This is a strategic need. Today, over 72% of titanium refining capacity is in China and Russia. And this is obviously not a great situation to be in, especially from a national security strategic need for the United States and other Western countries, because a lot of defense applications rely on titanium metal. It's not just lightweight and very strong, so used in US Air Force, US Army applications, but it's also has superior corrosion resistance, so it's used extensively across Navy applications, submarines, surface ships, things like that. The M777 howitzer is a lightweight cannon. There's 100 of them deployed today in the Ukraine war against Russia. They're helping to win the war. They're able to be helicoptered into position, manufactured by BAE Systems. Originally, the titanium metal came from Russia for those cannons. So it's important to have this Western world supply of titanium metal, not just for the commercial applications of titanium metal, which are very important, range from aerospace, medical through to industrial applications, but also for the national security need. The other reason we get excited about titanium metal as we started developing the business and as we started interacting and realizing that there was this process technology out there that could lower the cost, we also realized that that technology would also address the significant shortcoming in the titanium supply chain today, which is that it's one of the most unsustainable supply chains for a metal or for a material, structural material used today. It's one of the most, in today's process, it's one of the most carbon intensive metals out. We hope to make it one of the least carbon intensive metals out. We're completing a life cycle analysis as we speak, going through peer review, and we hope to announce that to the market very soon. But we see that we can bring down that carbon intensity of titanium metal to be even better than a lot of the other well-known metals out there. You'll see it here. It's far higher than stainless steel and aluminium. We hope to bring that significantly down and to be more competitive from a carbon intensity standpoint than those metals as well. In addition to that, as I explained, the titanium supply chain today is not circular. Whether you have the scrap generated in titanium metal, today titanium metal, most of the scrap, because it almost lasts forever in applications, most of the scrap is not end-of-life scrap. It's in the process of manufacturing titanium metal components, you create a lot of scrap. There is an example of a titanium metal component today that's used in a military application. It's a 370-pound, essentially airframe. It comes from a 4,000-pound block of titanium metal. Now, some of that scrap, probably 50% of it, is able to be remelted, but the other 50% is machining, turning scrap, where essentially the titanium has picked up too much oxygen. Technology is able to deoxygenate that scrap titanium metal that has typically been downcycled or gone into the steel sector or gone to landfill. We're able to take all that scrap and recycle it. In addition to that, today the titanium sector cannot take 100% scrap and produce a 100% recycled product. we can create that. So we address both strategic needs for recycling by not just taking almost all forms of scrap, but also being able to take only scrap to create titanium metal products. And we're doing that today, and we're already supplying into products today, which we'll talk about. Then the other big, exciting potential for us by lowering the cost of titanium metal and bringing this superior metal into competition with other materials, especially stainless steel and aluminium. And by having this sustainable source of titanium metal, we can really start seeing huge market opportunities where titanium metal has been restricted thus far. So stainless steel, huge market. It's out there because it's strong and it's corrosion resistant. Well, titanium metal is far stronger, far more corrosion resistant, and it's lighter weight. In aluminium, we're not talking about replacing coke cans, but we're talking about structural applications where titanium metal could and should be used if it's more competitive. So huge markets out there. We just announced a deal with Canyon where we will be looking at replacing some of the carbon fiber or aluminum components with titanium metal. So very huge markets out there that even if we just only take a little slither of these markets, we'll be a highly successful company in the next 5, 10, 20 years. So what is our solution? Our solution is based on a patented revolutionary technology based on breakthrough science, which was only discovered in 2016 by Professor Zach Fung, which allows for the direct refining of either titanium minerals, titanium dioxide, or titanium scrap, which has high oxygen content in it, deoxygenating all that into purified, refined titanium metal. It's essentially as simple as taking scrap, crushing it, and putting it through our process to deoxygenate it and creating titanium metal refined powders. We can do some pre-processing there where we crush it and create spherical titanium metal powders, deoxygenate those, and create high-value titanium metal spherical powders for the additive manufacturing or 3D printing industry. This is a zero carbon process. There's a scope 1 and scope 2 zero carbon emissions, and it's a fully recyclable process, as opposed to the current supply chain, which has had to go through a very carbon intensive, very nasty process, multiple steps to create titanium metal products, has led to not just the refining of titanium metal being expensive, but the end result of our titanium metal part or component being very expensive. We can completely compress that supply chain, make it cheaper, make it less complex, and ultimately offer titanium metal parts and products that are competitive with their counterparts, stainless steel and aluminium, carbon fiber, or other products as well. So it's a complete revolution to the titanium metal supply chain. This is not a small process optimization to the current supply chain. It's a complete upending of the supply chain, creating titanium metal powders, and from there you can form it using 3D printing or using traditional powder metallurgy applications, traditional applications to make bars, plates, wires, or we can 3D print to make what we call near-net shaped components. So what are we doing today? We are producing titanium metal powders today at our industrial pilot facility in Salt Lake City, Utah. This was the original pilot facility which the Department of Energy funded. So when Professor Zach Fung had his scientific breakthrough in 2016, he was funded by the Department of Energy to scale it from the lab scale through to what we would call a semi-industrial scale. This is done outside of the University of Utah in a facility we control now. This was initially funded by the Department of Energy. We took over operation of the facility at the start of 2022, and we've done a few things there. We've spent some capital to optimize that facility, but more importantly, we've put a great team around that facility and developed all the operating procedures that we need to take it to the next scale. We produce a significant amount of titanium metal powder for an industrial pilot facility today in a setting which is a small scale manufacturing setting. You can see our people there, they're actually standing on top of the furnace, which undertakes the key, what we call hydrogen assisted magnesiothermic reduction process, which is where the core science happens. I like to say where the magic happens. This is an industrial scale furnace that it's done in, that came from China. So we're doing it today, and we're producing titanium metal powders today from 100% scrap. So one of the only companies, or the only company in the world that's doing consistently 100% recycled titanium metal powders and producing then products from those powders. Now we're using those powders to interact with customers. We have enough production where we can do some small volume production runs, like in the luxury goods sector, where we've already secured a partnership and a contract with one of the Richemont groups, an $80 billion luxury group listed in Europe. It's Cartier, Van Cleef, RWC, and Panerai. We are supplying watch blank cases into Panerai. Those are then taken, they're machined out. Final machining happens, and we're able to take all the scrap from that machine and recycle it, and we're producing luxury watch cases. That's a very customer-focused product, where the customer is very much focused on the sustainability of the product as well, the recyclability of that product. And it's a luxury application. It's a very expensive piece of jewelry, collector's items as well, that cannot break, that cannot have surface defects. So our titanium metal into that industry went through what is a pretty significant qualification process, and came out as being just as good as even better than the current industry can supply. So we're supplying into that with the powders. We take our powders, we 3D print those watch cases, we supply them to Switzerland. Been just announced a agreement or collaboration with Canyon, one of the preeminent bicycle manufacturers out there. We're entering the bicycle supply chain. We've announced with various 3D printing groups, most recently with SLM Solutions, was bought by Nikon Corporation last year for $623 million, where they use a lot of titanium metal in their 3D printers. They're a 3D printer manufacturer that has sold over 800 machines worldwide. A lot of those machines, well, almost all of them, can run on titanium metal. Those customers want to buy powder, titanium metal powder for those machines, and we're working with SLM to supply into that customer base. And of course, because of our intersect with this huge national security issue of titanium metal, especially since the Ukraine-Russia war, we work a lot with the US Defense Force across all branches of the military. We won a US Air Force Research Laboratory contract at the start of the year. We also announced that we're working with Cover Pumps, one of the preeminent supplier of pumps in the US Navy, where we're going to be looking at introducing not just an American-made titanium metal to the US Navy, pumps made from titanium from the US into the US Navy, but also be able to give the circularity that was previously not possible, so that you can take broken parts off ships, put them through our recycling process, reprint them, put them back on a ship, keeping that ship in service and keeping it out of dry dock. So where are we going over the next really 6 to 12 months, 18 months? We're scaling. We have been producing enough powders to interact with customers, to secure customers, but to also get some low volume production out there, and to start talking with some customers from some larger industries as well, which I guess we'll talk through later. But we need to scale the business, and we knew this from over 12 months ago. So we did a few things here. We went through and did full detailed engineering and design on what a scale-up should look like. And in September last year, we announced some numbers around what that looks like. And in addition to that, we started a national site selection process for where our new facility, our scale-up facility, should be. And again, in September last year, we announced with Governor Youngkin, the governor of Virginia, that we will be locating in a existing shell building, 50,000 square feet in Virginia, in Halifax County, Virginia, to build our first commercial scale, large scale facility. We announced last year that this facility will target 125 metric tons per annum. We aim to move into this facility later this year. It's about a $20 million capital cost, of which about $4.5 million is being spent by the Halifax County and the Commonwealth of Virginia. We are now going through and finalizing the detailed engineering, but we are also looking at how much scale we can get in this existing facility over the next 12 to 18 months. We believe we can get far larger, far more than 125 metric tons per annum. We will be coming back to market fairly soon with updated numbers for the 125 metric tons and some guidance as to both CapEx, OpEx, and production scale for our business in this facility and over the next, say, 5 years. This facility will be doing essentially exactly what we're doing in Salt Lake City, only will be the first of its kind to be at a large commercial scale manufacturing titanium metal powders and making significant cash flow for our business. Over the longer term, though, we aim that to continue to scale this business, take that initial titanium demonstration facility, get more scale there, potentially locate similar facilities across the United States, and then eventually backward integrate with our titanium, with our Titan project in West Tennessee. We see that this business, once we get to 125 metric tons, get larger scale, get even larger scale after that. We've publicly announced that we have aspirational targets for 10,000 tons per annum. That's a significant business. We believe we can hit that just on scrap metal, but we can go larger. And to go larger, we eventually will want to have that full integration. We lower the cost of titanium metal, we make it more sustainable. I think the sky's the limit for how big we can make this business over the next 5 and 10 years. So for us, in the short term, we see a lot, and in the short to medium term, we see a lot of major value-adding catalysts for our business. We are NASDAQ and ASX listed. We're taking a very similar pathway to how we built Piedmont Lithium. We're working very closely with our customers right now. We're looking to secure additional customers. So we showed those target markets there, which I didn't talk about much, but we can talk about in Q&A, where we see ourselves being a big participant in supplying titanium metal into some very exciting industries. In addition to that, we see some big catalysts in just building that business, getting to first cash flow with our titanium metal powder production and growing that over the next 12 months, 18 months. And then we also do see developing our Titan project as having some major value-adding catalysts, especially around permits. Today, it is one of the largest titanium mineral deposits in North America. It's got a nice co-product of monazite and xenotime. We completed a scoping study last year. We see by permitting this project and getting construction ready, that we can unlock a lot of value, not just a lot of value in the long term for the integration, but a lot of value for shareholders in the short term, because this is an asset where there is a lot of participants in the market today who would like those minerals outside of our business of titanium metal, that would love to joint venture or get involved somehow with the company and pay IperionX to be involved in that company. So with that concludes the presentation. Jane, I'll hand it back over to you for questions.
Wonderful. Okay. So can you provide some background on the register and probably just a little bit even more importantly, the board and management's holdings?
Yeah, absolutely. So we're lucky, even though we're a relatively small company, well, not small company, we're still a micro cap, small cap company in the whole scheme of the market today, that we already have been able to attract very strong institutions to the register. We have Fidelity out of Boston, Fidelity Management Research, that holds 10% of the company. And then we have Fidelity out of Asia, Fidelity International, that holds 7% of the company. In addition to that, we were able to secure a mid-tier investment bank, B. Riley, their private investment arm, that holds just a little over 5% of our company. Now, we also, as a board and management team, we hold approximately 30% of the company. That institutional shareholding is testament to, I think, the vision that we have. When we talk with whether it be your average investor on the street all the way to your major fund manager, like what we have in Fidelity Management Research, and talk to them about the vision of building a sustainable supply chain of titanium metal and a low-cost supply chain of titanium metal, most people want to get involved. And to be able to secure those sort of investors early on in the life of our business is definitely testament to the vision that we have and the potential that we have as a company.
Thank you for that, Taso. So another one, so in the most simple terms, what is the key difference between our technology and the existing titanium processing methods that are used by industry?
So it's a good question. Titanium metal is corrosion resistant because it forms a skin of titanium dioxide. That skin is impervious to corrosion. Those chemical bonds are very, very strong. Titanium mineral is the same sort of thing. It's a titanium dioxide, essentially. It's an oxide mineral in its natural state. So whether it's scrap, you don't want the oxygen on the inside of the metal, in the bulk of the metal, because it makes it brittle. You want it on the outside. So if it's scrap, like turnings, grindings, shavings that have picked up oxygen because of the surface area, you can't remelt them. or titanium mineral, you just can't take it and put it in and melt it. So you have to deoxygenate the titanium metal. You have to refine it. Those bonds were really hard to break. And so that Kroll process was invented, which is a carbon intensive, chlorine intensive, energy intensive process, very nasty, leads to that very long, drawn out supply chain, multiple steps, create a big ingot, from an ingot, then extrude out into different products and components. Very costly, very carbon intensive, very energy intensive. The key difference here and the key science behind what allows us to do what we can do is that Dr. Zach Fong in 2016 discovered that if you introduced hydrogen into whether it's titanium scrap with high oxygen or titanium mineral, that essentially those bonds slightly destabilize. So we call it hydrogen-assisted magnesiothermic reduction. Those I like to call it akin to putting a scalpel to what was a very brute force process with the traditional process. It's essentially slightly destabilize those oxygen bonds, allowing for a very simple reduction to happen or refining process to happen. And it's the core basis of, we've got 40 different patents. It's the core basis of that deoxygenation, the ability to deoxygenate titanium scrap metal or titanium mineral, which allows us to do what we do today.
Thank you for that, Taso. You touched on this in the presentation, and webinar attendees will note that the company recently announced an agreement with Canyon Bicycles to develop a more sustainable titanium-based supply chain for that sector. So can you tell us a little bit more about what that deal means for IperionX?
So the micro-mobility sector, which we like to call it, which is not just bicycles, but electric bikes and scooters, things like that. Micro-mobility is a big growth factor, both in Europe, US and Asia. And we see that as a huge market, huge opportunity there. And so with Canyon, we're entering that market with one of the most preeminent direct-to-consumer bicycle manufacturers. Our Canyon is a very high growth, very well-known bicycle manufacturer out of Germany, Koblenz, Germany. They've got investors like LeBron James, who invested in them last year. Tony Fadell, his ex-senior vice president of Apple, who invented the iPod, invested in them in 2020. Very well-known, very highly respected bike manufacturer. They typically make aluminium and carbon fiber bikes. They would love to get into titanium metal. Titanium metal has got some superior properties to both of those materials, but more importantly, it is far more sustainable than both of those materials in the bicycle sector. So you can eventually have a bike which is not just better performance, but also far more sustainable in the whole scheme of things in that bicycle sector. And this is a sector which is very much focused on sustainability because it hits the consumer, just like luxury watches as well.
Thanks, Taso. The next one, and you did mention this in your presentation earlier, but so IperionX recently won the US Air Force Research Laboratories Challenge. So can you provide a little bit more detail about that competition and how it ties into the work in the US defense sector?
Yeah, absolutely. So US Air Force Research Labs is a serious lab. It's funded to the tune of $6 billion a year by the US government. It is where the cutting edge development of weapon systems happens, new generation fighter jets happening, hypersonic missiles, which is one thing that's big in the defense sector today. So they do a lot of prototyping. They use a lot of 3D printing of titanium metal, a lot of titanium metal use in advanced military applications, as you can imagine, because of its properties. So these broken prototypes, they obviously, missiles, they shoot them, break them. I mean, what do you do with the broken parts, the broken prototypes, any failed builds? And you can't just get rid of these. One, you can't recycle them because the current titanium industry, it's tough to recycle them, uneconomic. But in addition to that, what do you do with those scrap components? You can't exactly put them into a landfill. They're classified components. So we can take that and be able to recycle it. The Air Force Research Laboratories wanted to do it from last year. They realized they were having this growing stockpile of these broken components made out of titanium metal, made out of 3D printing. And the 3D printing powders are expensive themselves. So they went out to industry, all of industry, and put a challenge out there to see who could manufacture or who could recycle these components, not knowing that we were already doing it. And so we entered that challenge. We won against all the major players that came into that challenge. And we're able to provide a critical need for US research, the US Air Force Research Laboratories, which we believe will grow into much larger things across US Air Force and other parts of the defense industry as well.
This one's come through a few times actually. So are there any other topical sectors that the company is focusing on? For example, the green energy as an example.
Yeah, absolutely. And I should have touched on it in the presentation a little bit better, but you know, we've been working across a lot of industry verticals where we see the benefits of titanium metal, especially sustainable titanium metal and lower cost being supreme. So definitely we have our great customers and collaborations we're building in the existing markets that we're already penetrating into: luxury goods, defense, additive manufacturing, bicycles. But we see huge markets in a few other big areas. One of those is the hydrogen economy, green hydrogen. Electrolyzers, the electrolysis of water with electrolyzers uses a lot of titanium metal. It needs to be corrosion resistant, but it also needs to be strong. So they use an immense amount of titanium metal in the green energy or in the green hydrogen space. And we have a lot of growth in that space in the United States, in Europe, I believe here in Australia as well. That titanium metal today comes from China. So by being able to supply a low cost, but also a more sustainable source from a Western country, from the US, is a huge benefit to those groups that are looking to build hydrogen, green hydrogen capacity across the world. And we forecast that that's going to be is already a significant market. That could be 10% of the titanium metal market by 2030. In addition to that, we have, you look at consumer electronics. That's one area where we see it as a natural vertical that's very similar to luxury goods. What this is, watch housing is very simple. It's just a housing that we supply. That's whether it's a luxury watch housing, a smart watch housing, a smartphone, a laptop housing, it's all the same. The superior nature of titanium metal, being corrosion resistant, being lightweight, being super strong, is a huge benefit to the housings of consumer electronics, especially as they get lighter, as they want to continue to make them thinner, lighter, stronger. This is a huge market opportunity. In addition, that market is similar to luxury goods, similar to bicycles, is a direct-to-consumer market. The consumer wants those products to be more sustainable. They want them to be recycled. So we can offer to that market a product which ticks all the boxes for the OEMs in that market, whether it be that they want the benefits of titanium metal, the benefits of a low carbon supply chain, but especially the benefits of a fully recycled metal. That's huge. And then the other big market that I guess we're working into is the market that the Department of Energy funded the technology for. Department of Energy funded the technology to be developed to lower the cost of titanium metal to get into the automotive sector. And we see some huge opportunities there where we've been working behind the scenes with tier ones and OEMs in the automotive sector across the US and Europe, where there's opportunities to start introducing more titanium metal into the automotive sector. All those markets, you know, are very large. They can be very, very large. The qualification period is relatively straightforward, and we've been working diligently as a team with our partners in entering those markets, and we hope in the short term to be able to make some announcements around that.
Thanks, Taso. Quite a few questions coming through, so bear with me. So when do you expect the titanium demonstration facility to be operational?
So we are going through the upfit, or well, the government is going through the upfit right now with the titanium demonstration facility. The agreement with the government, they incentivized us to come there. We did a national site selection survey process. We put states in competition with each other. Virginia came out with a great incentive package, very strong political support. Governor Youngkin, Senator Warner, Senator Kane got great support there. They're brilliant pro-business, pro-development group out there. The idea is that they do the upfit first, the $4.5 million, electrical work, firewalls, things like that. They then hand the building over to us sometime in the second half of this year. We have already some of the long lead time item equipment secured, and we would intend to start delivering equipment towards the end of this year and start commissioning towards the end of this year. The idea is to then be operational, either call it first quarter next year. Could be at the end of this year, but definitely into the first quarter next year. And then from there, as I said, we are going through some numbers now where that facility, we know we can take it larger. We're just going through the numbers as to how big, just within that facility we can go in the short term. We will come out with some guidance to the market as to how big we can go over the 2024-2025 timeframe in that facility.
Thanks, Taso. You kind of answered that next question, but can you please elaborate a little bit more on the company's scale-up strategy, noting that the scale-up is a common challenge to industrial commercialization?
So this scale-up is actually quite simple. It's all off-the-shelf equipment. We've had a couple of engineering groups from third-party investors come through that are doing a lot of work on our business, and also our own third-party engineers that we're working with on our scale-up plans. Because this is all off-the-shelf equipment, we're already doing it in an industrial scale furnace in our pilot facility. There's some pretty straightforward scale-up plans that we have. We're not changing any of what we call the critical dimensions within our furnace. Everything else we do is off-the-shelf equipment as well, whether it be crushing or whether it be drying or sieving or packaging. It's all very off-the-shelf equipment that we utilize. So very simple, very straightforward. Importantly, the furnace that we secured, we ran a hot test run of that furnace in the last few weeks. We will come out to market with the results of that, but we are very confident that we've hit a lot of the risks up front, and we've been able to mitigate those risks of scale up. We operate not at a lab scale. We operate at a small industrial scale today. We operate an outstanding team that has come from industry today, and we operate it at a scale which you can quite simply see how you can take it from there to that larger scale. So we think we've mitigated those scale up risks. And this is not like a lot of other technologies where you need to build $1 billion facility. And if something goes wrong on $1 billion facility, even 10%, that's $100 million out. This is a fairly straightforward, fairly low cost scale up that is then very modular. We feel that it's mitigated. We are highly confident in the scale that we'll achieve. And we're doing it in the short term. In the next 12 months, it is going to happen, and it will be a revolution to the titanium industry.
Thank you.
It's a good question.
So next one, given your relationship with Panerai, is there a potential for similar engagements with other companies who produce watches and smartwatches?
Yes, absolutely. So naturally, Panerai is one of the preeminent brands in the luxury watch sector. Their trade show Watch and Wonders was just on in the last few weeks in Geneva. With Richemont, we've got obviously engagement across the other brands as well. But naturally, if it's good enough for a luxury watch of that caliber, it's good enough for a smartwatch, a smartphone, things like that. So we're highly confident in the ability to parlay that success in the luxury goods sector, which is growing. We are growing, and we're going to be making a very big name for ourselves. That first luxury watch is going to come out this year, but we are going to able to parlay that into similar sectors. We call the luxury goods sector and consumer electronics sector two different verticals. Really, in my mind, it's probably one vertical with the luxury goods at the top, and then jewelry and watches at the top, and then naturally, as you go through, it's smartwatches, smartphones, things like that. So absolutely, we're parlaying that into consumer electronics.
Taso, now to Titan project. So there was a 2022 scoping study completed at the project. Can you tell us a little bit more about the study, the project, and what shareholders should be looking forward to from that side of the business?
Yeah, so Titan is important for our long-term strategy. We can take titanium minerals from the open market and process them eventually as well from other players. There's no doubt about that. But having the Titan project gives us a bit of that raw material security of supply and gives us a hedge against rising titanium mineral prices. You can imagine if the titanium mineral market is in deficit today, in short supply today. If we put more pressure on that market, prices will rise, and we may struggle to secure what is a market which is in short supply. So having the Titan project is a hedge against that, and that's why it's part of our business, especially part of our long-term business of backward integration. It is a 11,000-acre property that we put together in Tennessee, West Tennessee, between Nashville and Memphis. It is the largest titanium mineral resource in North America. It's also got a very nice co-product of the rare earth minerals and some other minerals, but especially rare earth minerals, monazite and xenotime. We did a scoping study last year on it, came to about a $700 million NPV. So great project as a standalone heavy mineral sands project. And it's a traditional heavy mineral sands project, so it can be done sustainably. But since then, we've been really focused on getting some of the long lead time items completed for the development of a project like that. So we've been deep into completing our feasibility level metallurgical test work, and we hope to come to market very soon with the results of that. But then more importantly, we've been very focused on the development of or the permitting of that operation. We've been very focused on that with the community. Me and my VP of Geology and Land, Jonathan Lord, we wrote a children's book to try and educate the parents and children of the communities how the project will get developed. It's called From Tennessee to Mars. People can see it on LinkedIn, or just put in From Tennessee to Mars. You can see it there. But we've been very focused on that, and we guided the market last year to the end of this year to have those permits complete. We are quietly confident that we think that can be done far sooner. So I think the Titan project, whilst we're very focused on building that recycled business first, getting us into cash flow that way, we can build a big business on just the recycling of titanium metal, creating a circular, low-cost source of titanium metal for the Western world. The ultimate value of Titan is in the long term that backward integration, but in the short term, it also gives us optionality with other groups who are interested in the minerals that are in short supply, especially the rare earths and the titanium minerals.
Thanks, Taso. And just finally, so what are you most excited about, and what should shareholders be looking forward to over the next 3 to 6 months?
Yeah, absolutely. I'm very excited about customers. That typically is a defining moment for companies, getting very strategic, large-scale customers on to not just validate what we're doing, because of course some of the large customers, most customers come in and do a lot of work on the technology, test our powders, break products made from our powders. Like that's what we did with Panerai, in the US Air Force, with Canyon. A lot of work done on the diligence of our titanium metal. Is it as good as virgin metal? Yes, it is. Does the process work? Yes, it does. Things like that. But securing those customers really validates that in the mind, I think, of investors, both retail, high net worth, and institutional investors. So the right sort of customers, like when we secured Tesla for Piedmont, we went, I think we tripled or quadrupled on the day we secured Tesla. So securing a strong group or more strategic customers, big brand names across other industries is very important for us, whether it's consumer electronics, whether it's automotive, whether it's industrial hydrogen, green hydrogen economies is a big one. But then just building the business as well, getting our project or getting our Virginia facility up and running and getting into cash flow is just going to prove it out. That naturally is going to create value over the next 12 months by having the Titan project permitted. That naturally creates value. It's that long-term value, but short-term, it allows us to maybe attract a joint venture partner who will pay us to be involved in that project. So that's a lot of value there. But I'm definitely this is a very exciting industry to be in. You go from being able to supply in the luxury goods sector all the way to the industrial sector, to the automotive sector, consumer electronics sector, to the defense sector. It is a very exciting business with very high growth and pretty much almost unlimited addressable markets. So I'm very excited about just building business and getting the right customers involved and right partners involved in the business.
So, well, thank you so much for the great presentation. Should we have missed any of your questions, please feel free to reach out via the contact details on the bottom of our ASX releases. But I'd like to thank you all for your time. Thank you, Taso.
Thank you, Jane.